Artificial intelligence is taking humans to places we couldn't go before. That's what makes this the age of with. The next question is, where can humans take AI? From the boardroom to the college lab, the Deloitte AI Institute is bringing forth insights and using our deep knowledge of all aspects of AI to make sense of this complex ecosystem. We are not just preparing to meet the AI future, we are shaping it together.
And good afternoon, and welcome back to the 16th annual MIT CDOIQ Symposium. Just in case you'd forgotten while you're away for lunch there, this is track one, the environment, social, and governance, better known as ESG, better data insights enabling companies' ESG goals to ultimately benefit society. I'm your track producer, Robert Lutton, Vice President, Sandal Consultants, and I'd like to welcome you to a very interesting session called the Lifeblood of ESG Strategy. So before we introduce our guest speakers, I've got a few housekeeping notes. As we mentioned before, this session is being recorded. We're beaming out to millions, well, maybe not millions, but we're beaming out to the folks live. So you have the chance to enter and use the Q&A feature. So please do that. I understand that Dilip will be asking the audience online if they've got any kind of questions. We'll be monitoring that. We'll also be monitoring on site here. So we do like to have a show of hands if you've got some questions, and there's mics there at the end. So with that, it is my pleasure to introduce our main speakers who always love to come to MIT, so I believe. So the first one is Dilip Krishna, who is the Managing Director and Chief Product Officer of Cortex AI from Deloitte. And I was just talking to Stephen, and I said, this is a cool job. And he said, well, not really. He's only 25, and his name is Stephen Ward, the climate data scientist from Deloitte. So Dilip, I'll pass it over to you.
Thank you, Robert. Hello, everybody, and it is a distinct pleasure to speak to everybody here, both in the audience as well as certainly folks online. As Robert mentioned, we will be going through the slides, but going through them fairly slowly, and encourage folks to ask questions online as well, and we'll try to answer them through the session, make this as much of a conversation rather than a monologue, which, trust me, is much less fun. With this, let me get started with talking about the topic here, and really, what is the relationship of data to ESG? The first thing probably to talk about is, what is ESG? And ESG, of course, stands for environmental, social, and governance. It sounds like a cool series of words, but really there are huge topics under the covers, and environmental deals with not just climate, but also sustainability related topics, and we'll spend a lot of our time talking about that today. Social deals with a whole series of social related topics that you can think about, but which have really interesting implications, like department stores' ability to carry, to limit the number of rounds of ammunition sold, for example, could become a social topic and have real impacts to institutions. And governance, of course, has a lot of different connotations in terms of all sorts of things that go bad, and how do corporations, whether they are commercial entities or governmental entities, how do they truly govern the activities of the people that represent them. Why is ESG important? For many reasons, really, both human reasons, which I think we can all relate to, but increasingly, ESG is becoming a topic of importance from a financial standpoint. There are many investor-driven initiatives now relative to ESG. There are lawsuits being filed against companies who claim to be green, as it were, and are not so. There are employee-related aspects to this, especially in this day and age, being environmentally or socially responsible is important to attract talent. And of course, increasingly, and we'll talk a little bit about this as well today, there is a lot of focus now in terms of upstream producers, suppliers, clients, and them thinking about the ESG footprint, as it were, of a firm. The challenge, of course, with all of this is it is a very broad topic, and as data geeks, I'm certainly one from a long time, and I know a lot of folks in the audience are. Anytime we have a complex problem with a complex number of, let's call them use cases, the data becomes extremely complex as well. And so that's the other reason why I find this incredibly interesting from a data standpoint. What we are going to do today is talk a little bit about climate specifically. Within that broad framework that I laid out, climate is one little sliver, if you think about it. It's a big sliver for all of us, of course, but it's only one of several topics here. And we'll use that to illustrate the data challenges, but you can extrapolate from there onto all sorts of other issues. To sort of go through very quickly what the climate-related challenges are, and I'm sure everybody knows about this. Greenhouse gases, carbon dioxide, but also things like methane and other greenhouse gases are heating up the planet. Now, how they do it and what the feedback effects are, those are a lot of the unknowns that we have, and they actually lead to a lot of the data challenges that we do have. And the challenge, of course, is how do we reduce that at the end of the day. So that's really all the topics that we will cover. Like I said, please do chime in. We'll have some pauses in the middle of what we are talking about here. And Steve, would you like to add something else to it?
Yeah, so I think in Dilip's opening, he probably used the word complex 6 times. And probably could have used it another 6 times. Because the reality is that this isn't simple data. It isn't necessarily big data. It isn't necessarily a massive, heavy compute problem. But it is a lot of different data from a lot of sources. And the ESG acronym, unfortunately, doesn't stop there. We've got TCFD, TNFD, SASB, ISSB, CSRD, GHG, GRI, all of these frameworks, these guidelines, are driving and putting guide rails around how we operate, manage, disclose, report, understand, study. At the end of the day, all of this boils down to being transparent about how you're impacting the environment and how the impacting is impacting your operations as an organization.
Excellent. So let's dive into what climate is all about. And at a high level, one can think about the climate problem as 2 things. First, there is a need to stop the increase in carbon dioxide and carbon dioxide equivalent gases in the atmosphere. One metric, one commonly cited metric is today we are variously between 417 to 423 parts per million of carbon dioxide, 0.04%, something like that, in the atmosphere. Before the Industrial Revolution, we were at something like 280. So it's significantly increased since then. And that continues, and a warning sign, a big red warning sign starts flashing when we get to something like 450 or so, which then leads us to calculate what they call a carbon budget. How much more carbon dioxide can you throw into the atmosphere before we are all doomed? And understanding that, and then how do we mitigate those numbers to a point where we not only get to what's called net zero, which is how much do you put out, how much you take back in, and then, in fact, you take out of the atmosphere. Those are all big topics. And every organization out there is now under pressure to put out some target. Well, I'll get to net zero by X. I'll get to net zero by 2030 or 2050 or 2070. And different organizations have different footprints, of course. So that's one big challenge with climate. The other related one is how do you convert your organization to a green organization by using energy that is green, by not burning fossil fuels, by not producing product that is fossil fuel rich in some way. And that's not just, by the way, oil companies, it's anybody, somebody who produces phones or people who produce food stuff that then can rot and produce carbon dioxide. So there's lots of different ways in which you can generate greenhouse gases, and one needs to think about that broad range of things. And that leads to what's called the circular economy, which in broad sense is how do you sort of put into your product things that can get taken out. So think about recycling and those sorts of concepts. The other side of this is, well, it's great, let's try to not pollute the atmosphere anymore and save ourselves, and then let's also understand that the chances that we will save ourselves are diminishing by the day, so what is plan B? So it's called adaptation, and adaptation has many different angles, of course. If you're a financial services firm and you have huge populations that are, or your big footprint even might be near coastal areas, what do you do over time as your houses that you have mortgaged are slipping into the ocean? That could be one example, but other examples are if you're a farming and an organization in that space, how do you deal with the fact that 20 years from now your farmlands might actually not generate food anymore? And then how do you think about where you move? So those are all aspects of adaptation. We can go on and on and on, but what this really results in is a notion of scenario analysis, which I imagine a lot of folks are familiar with, putting out a whole series of scenarios, then using data and using analytics to determine what the impacts are on anything. And this could range from commercial corporations to the armed forces to governments to cities, and everybody has to do this. So this is a very wide-ranging problem, and the data, therefore, that goes into those calculations becomes very complex in a whole variety of aspects, and that's really what we'll get into talking about in the next little bit. Steve?
Yeah, so thanks, Dilip. You're probably wondering, why does Deloitte have a climate data scientist on staff? Well, in order to understand how we can recommend mitigating what's going on, how we can adapt to what's going on, we really have to be able to understand what's going on. So I've spent the last 25 years of my career in the trenches, taking ice cores in the Himalayas, rainforest in Colombia and Brazil, gathering soil samples there, looking at inland lake cores to develop historic storm intensity proxies, sweating in the heat, but sitting in all of these hazardous environments and geographies that are very dynamic and changing in our lifetime. And in that time, the entire narrative has always been what is happening or what has happened to the Earth. We need to shift this narrative now to what are we going to do to change it, to mitigate it, to adapt to it. Data is the vehicle that's going to take us there. And it's our opinion that data is the single most important commodity for an organization on its ESG journey. As with any new technology, any emerging trends, we see a huge explosion in technology and software and tools, and those are fantastic. They're going to make your job easier. But they're ephemeral. They're going to come and go. There will always be another one. There will always be a better one. We'll always have a better understanding, a new methodology. The data underneath the hood for an organization is absolutely critical. And so we're going to shift and start talking about that a little bit more. But just to give you an illustration, and many of you have probably seen this, of the complexity of some of this data. We're going to use GHGs, or greenhouse gases, as an example. So the requirements, or the recommendations right now, soon to be likely requirements, are that you measure these. You calculate an inventory. But it's not just one number. You have scope 1, scope 2, and scope 3 emissions generated from any given location or asset that a company owns. Scope 1 being the sort of direct fuel combustion or consumption within an organization and direct emissions. Scope 2 being those purchased or acquired emissions. And then Scope 3, the elephant in the room, the really difficult part is everything else down your supply chain, everything that you consume, everything you produce, and the end life cycle of that product and its carbon footprint. Now, it's not just these three calculations. Think about an organization that has 700 to 1,000 locations worldwide. Think about the fact that there are 9 core greenhouse gases that have to be accounted for. It doesn't take a mathematician to quickly understand that you're up to thousands of calculations that are based on hundreds of rows of data. It can become extremely messy really quick. And the importance of getting this under control, the importance of proper data curation, provenance, governance, is that these numbers have to hold up to an audit. It's no longer good enough to just report it and say, this is what we did. You've got to open the curtains a bit and explain exactly how you got there, explain where those data came from, how they were curated, how they were managed, talk about version control, talk about metadata documentation, and all of the associated artifacts that come along with it in order to pass that audit and pass the smell test and credibility required by our investors and our stakeholders and the public today.
Yes.
Actually, Stephen, if I can interrupt you, there is a kind of timely question here on this topic. It says, why does ESG focus on carbon emissions and not other harmful greenhouse gases like methane?
Well, it actually does. Carbon dioxide is the villain of the day, if you will. And we're trying to wrap our hands around and control that because it's oftentimes the most heavily produced. But the other greenhouse gases mentioned, especially something like methane, which is from a warming potential standpoint entirely worse than carbon dioxide, is not as widely admitted as CO2 is. But all of those greenhouse gases, nitrous oxide, your CFCs, your HFCs, all of them have to be accounted for in a proper scope 1, 2, and 3 inventory.
Yeah, and if I can just maybe add in on that, this actually, it's a great question because it illustrates some of the mathematical challenges involved in this. So if you think about methane, if methane was a stable gas, just like carbon dioxide, and it lived the same for thousands of years, you just say methane is X times carbon dioxide, do an equivalent, life is great. Unfortunately, chemistry doesn't work like that. So what happens is methane actually degrades into carbon dioxide and other gases over time. And so the mathematical problem that you have is, and this is a statistical description problem, which then leads to a lot of math and data underlying it, is we have to start saying, well, methane is 86 times carbon dioxide within the first 20 years, but it may be only 30 times carbon dioxide within the next 100 years. So my prediction has to kind of say how long the prediction period is for, which tends to complicate matters a whole heck of a lot, which then, of course, needs a lot more information, a lot more calculations as well.
Go ahead to the next slide. So this is the fun part. Every time we engage a client, we begin with this data discovery process. It typically represents 80 to 90% of the work. And I don't want to marginalize the math and the analytics, but frankly, the calculations are pretty straightforward from a pure data science or physics or modeling perspective. Wrangling the data absolutely is not. Unfortunately, to date, a lot of ESG work in organizations has been taking place on local hard drives, in Excel, back of the envelope. And when we initiate this data gathering process, we often look like we're emptying out the evidence room from a police station. It's boxes of files and paperwork, unstructured, structured text. We're dealing then with models and having to combine models that are time series historic calculations that were then on building ensembles looking forward using Bayesian methods. Most organizations don't have the data scientists, the analyst in-house to handle those sorts of calculations. The granularities, people don't tend to understand or have a lot of spatial theory in their training. They don't understand modifiable areal unit problems. They don't understand the blending of scales, both temporal, spatial, horizontal, vertical scales that you're working with this data. So it becomes a bit of an ETL mess and standardization mess. And then formats. Yes, we get all of the typical formats, right? Everything from PDFs and JPEGs that we do some character recognition on, all the way through to your XML files, Excel files, JSONs, GeoJSONs. But then we get into some of the more difficult files to work with. How many folks in the room here have worked with CMIP data and NetCDF files, or GRIB files, or satellite image cloud-optimized geotiffs, and having to do band alignments with each of these? So this isn't in your typical sort of wheelhouse. And what you begin to find out is that for even a moderate-sized client or organization, these files can tend to take up quite a bit of room. We can get upwards of a petabyte of data for just a small company. So exposing yourself, understanding all of the different data formats that are out there. Unfortunately, there's not a standard right now. This discipline, this field is still emerging. Their standards are coming online, they're coming into place, but there's still not one gold standard to follow as far as an organizational or data schema template. So it does create that complexity. And I'm telling you all this, we're telling you all this now because we see it with our clients every day. And it's typically that the chief data officer, the data officer in an organization, doesn't always have a seat at the table, at the ESG table. And it's one of the first recommendations that we make is oftentimes it's housed in the finance officer's org, oftentimes it's sitting in environmental health and safety, sometimes it's its own sustainability office. More times than not, we do not see data represented at the table. Yeah. And so we encourage you, if you don't take away anything else from this conversation today, remember to get your seat at the table.
And I would say that last point is, I cannot emphasize that enough, because often the folks who are thinking ESG, thinking climate, and those sorts of topics are actually, they're not data people, so they don't understand the data challenges. And so they don't, it's not that they're excluding folks with this knowledge from the table, but they don't even know that they need to invite folks with this capability. To give one example that we've worked with, if you think about just measuring emissions, we're not talking about how to solve the problem, but just to measure it. One of the ways in which you estimate the emissions from a given company is what's called using emissions factors, and those are just simple multiplicative numbers that multiply, I'm spending so much on something, I'm spending so much on gas every year, and you multiply that by a CO2 factor, and you say, boy, that's how much CO2 we're generating. Now, if you think about that calculation, to Steve's earlier point, the analytics is dead simple. Think about where you go get that information. Sometimes it may be in invoices that are documents. And so you need sometimes AI, and that example is not a great example, but you have a lot of examples like that, where you actually need to oftentimes read documents using AI to get that data. And people with finance backgrounds and those sorts of folks perhaps may not make that leap to understand the real challenge and what it takes time is really gathering that information, which is in so many different formats like this.
So speaking of the data sources, there's not just internal data sources, right? You deal with quite a few external data sources that have to be pulled in, particularly as you get into more advanced or more mature ESG sort of clients. So when you're moving into that TCFD reporting and disclosure, when you're moving into the scenario analyses, where you're running multiple scenarios over multiple time frames, looking at financial loss estimation associated with physical risk, associated with transition risks. The complications of the methodology increase, and then the veracity of the data that you're leveraging. Typically in the US, in Western Europe, you're going to have a lot richer data sets. But unfortunately, our clients are spread out all over the globe. So now we're working with different quality of data, different levels of maturity of data from around the world for different assets, and we're trying to create a system where we can compare apples to apples across different assets and help understand what is truly material to an organization. Excuse me. Each provider of data tends to focus really specifically in on one form of data. So again, this gets back to the point that there are no silver bullets out there. There's not a one-stop shop. We use a combination of government-supplied sources, third-party proprietary data sources. We've developed our own financial loss estimation and damage functions. We combine those with government damage functions. We look at historic loss data from past hazard events, past perils, and then we do a lot of sort of constrained modeling, right? Probabilistic modeling to look forward and understand what's going to happen over time. All of these require access to a very queryable, searchable, retrievable, low latency data lake or data environment that we're currently building as we're using it, to be honest, because it's continuing to grow. We're continuing to discover with every client a nuance about that industry, about that particular client, that requires us to go out and find a different set of data, a new set of data to work with. And so I'm going to turn it over to Dilip here, I think, to kind of wrap things up a little bit.
So maybe just to riff on this topic for a minute or two more. One of the things that as we have started using this and building it over the past couple of years, the challenge, it's just a challenge in some ways of mass and quantity. So if you think about the fact that predictions, there's a concept called science-based targets, and it's based on the science. You say, hey, here is how far you have to decarbonize to keep under 1.5, well under 2 degrees and to a 1.5 degree a rise in temperature. And in order to do that, there are lots of math that needs to happen. Those predictions themselves are not from one place. They're from many places. And that's just one little tiny example of a data source. And you can just go around all the different types of ESG-related data, and you add it all up, and you're talking tens of thousands or hundreds of thousands of data sets. Now, the challenge then is, how do you actually go find the ones that you need? That's even the very basic problem is, how do you find the one that you need? To Steve's point, the quality is not the same, but they're not all mutually exclusive either. So there's a problem of understanding who has what type of data, how do you find it, and then how do you distribute that among all of the data scientists and the data engineers and so forth within the organization. So these are the kinds of problems that that we frankly are beginning to deal with at volume, and those are things that we see all of the large organizations that we work with beginning to grapple with. The bad news, I think, is we are in the early part of the journey, and this is only likely to intensify, and it really needs much more of a programmatic way of dealing with these sorts of problems.
So Dilip, just before you go on to the next section, there's the question here. They frame it interestingly, so think about it before you answer. So the question is, are we trying to be too comprehensive and not focusing on the most impactful factors, i.e. simplify the model for lower fidelity? It sounds like ESG will contribute to climate change by incentivizing a new cottage industry of number crunching.
Yeah, that's a great way to put it, and actually that is what we try to do, because truly the problem is massive. And I don't mean to speak in hyperbole, but in fact, I think it is very appropriate given where we are. The problem is massive and the problem is comprehensive. And it's actually in many ways overwhelming. We today don't know how to solve the problem of Greenland melting into the ocean. I don't believe we have a comprehensive solution for that. So what do we need to do is we need to think about what are the highly practical steps that need to happen in order to sort of attack the problem, both at a global level, then country by country, and then you break it all down to even firm by firm or organization by organization. The problem needs to be dealt with in that way for sure. Now, as you do that, one needs to determine the best ways to go about this and attack the problem in 1, 2, 3 ways. The real challenge with the space is we don't have the universe of the best ways to do this. We don't have the universe of all the ways to do this. Those ways are actually emerging as we speak, which is part of the reason why the data problem becomes so difficult to deal with and so comprehensive. The comprehensive nature of the investigation needs to happen. To give you an example, today, the notion of, if you think about this problem, at the end of the day, it's a big energy problem. If we had clean energy that could be turned on tomorrow, that could be used anytime by anybody, we wouldn't have a greenhouse gas problem. We just shut down all the oil wells, all the coal, and just use it. We don't have it. Of course, we can think about things like battery and so forth, but there are many areas where those sorts of problems, those sorts of technologies that we have today don't work. And so one example of a great technology that could potentially have an impact is what they call, it's hydrogen, using hydrogen, which of course, when it burns, it generates water, which is obviously not adding to carbon dioxide. All that's great, sounds great. The problem with hydrogen is it needs to be generated from green sources, solar panels, et cetera, and therein lies the difficulty. The cost of green hydrogen today is several tens of dollars per kilogram, and it needs to get down to $1, $1.50, $2 range in order to get to be useful. The question for operations to ask is, if my plan includes using green hydrogen in my operations, I need to get the data on all the things that I coded. That may not be the solution because we don't know if it'll get there. So we'll have to look at multiple options. And therein lies the complexity that I talked about. We can go on and on about a variety of different similar scenarios, but the real challenge is a lot of what we are trying to trying to do today is things that are not yet being fully invented and certainly not being scaled. So there's a lot of lack of certainty, I'd say, in the path that we need to take to get there, which is part of the problem that then devolves into a significant data challenge.
And I would add, maybe more simply, the answer is yes and no. There is great risk, right, that we cause more of a problem trying to solve a problem. In order to sort of mitigate that and approach that is, we realize there's low-hanging fruit. We realize there are activities, actions that can be taken by organizations that are going to provide the most bang for the buck and the greatest amount of return in the shortest amount of time. And we certainly make those recommendations. We also understand that not every single part of an organization, that the contributors to ESG problems, and we're just talking about the environmental side, right? We're just talking about the E right now. We're not touching S and G. But that's not distributed equally across an organization's assets. So we always take the approach of, I would call it a dimension reduction exercise, if you will, to really scale down to what is absolutely critical and material to an organization, but also presents the greatest opportunity. And we focus in on that rather than dissecting all 1,000 asset locations at a granular level for an organization. So we do keep that in mind, but I think that's a great question because there's absolutely, there's always that risk. And so it's a balancing act that we have to play with the organization.
Thanks, Steve. So now that hopefully we have effectively translated our often sense of hopelessness on how you deal with these problems, let's talk about what one might do to solve them and how one might actually, what are the techniques that one might actually use to address these problems. And I put this in the context of almost anybody here in the audience, whether you're dealing with a governmental entity or you're dealing with a corporation or other kinds of entities. The same kinds of problems and same kinds of activities need to be executed. And so in the I think, very common framework of people, process, and technology, of course, we can think about maybe the people side of things first. And the challenge, as Steve has described in the previous slides, has to do with the variety of data formats, and so on and so forth, plus the quality issues that a lot of us, I think, have dealt with in the past and continue to deal with. The challenge, of course, is the variety comes not only because of what we think of as traditional problems, quality, the various different systems that are sending data, and so on and so forth, but also it comes because the use cases are highly volatile. So I threw out a couple of examples earlier, but as you think through and as you start addressing the problems, the kinds of analysis that one is doing, the kinds of goals one has as an organization tends to change, and all those again are leading to different kinds of data that needs to be crunched and so on. So when we think about the people, there is distinctly a data engineering challenge because of the format differences, because of the types of data that you get, think of them as ETL challenges and so on and so forth, even though it's not your traditional ETL, it's data from lots of different sources. Steve mentioned satellites, for example. So having people who can think like engineers and take that data and put it into the right place, that's one. And then you have the data scientists, and to some extent, while the data science may not be as complicated, in many cases, be sure that complicated data science is absolutely needed. So this is not simply crunch some numbers and then get it into some Excel spreadsheet and put 2 + 2 = 4 and you're done. There's a lot more to it than that. There's a lot of AI involved in terms of optimization. For example, I think some of us, I'm sure, have heard of how certain firms are using AI to optimize the energy usage in data centers. That's a great example. So the use of AI to optimize is absolutely something that's there, and so data science is needed, which means that you need an organization that effectively combines data science, data engineering, and allows data engineers to rapidly sift between the hundreds of thousands of data sets that I talked about and effectively deal with the folks who understand the issues and then the people who deal with the technology. So that's one aspect that's really important. The second, of course, is technology to support these folks. I won't need to get into that in too much detail here, but obviously technology is needed. Technology is needed typically in large organizations across multiple locations and so forth, possibly even across global locations. And so this leads to a whole series of technological challenges. We did talk about the fact that a lot of this data is not big data, but some of it is. And when we start thinking about potentially using IoT data and so forth, the data can become significant in size. It does depend on the use case. It does depend on the organization. So those techniques, which I think are thankfully becoming much more tractable now, that sort of technology is absolutely relevant in this space. And lastly, processes. Given the lack of consistency, given the lack of coherence across all the data sets and the various sources and so forth, having solid processes on how to deal with all these things effectively is really important. The second aspect is these programs need to run for many years. So if a company makes a commitment that goes through 2040 or 2050, well, that's a 30-year commitment or thereabouts. that needs to be tracked. And as Steve mentioned earlier, increasingly your investors and so forth are becoming very scrutinizing these numbers to a high degree of certainty, to really degrees of auditability. So the need for strong processes to maintain the data, to maintain the fidelity of the data pipe, if you like, is really important over really a long period of time.
So,
I think
Dilip, you also, and Stephen, you talk about processes. I had a question come in about, says Deloitte has hired a climate data scientist. What recommendations do you suggest for larger organizations to follow?
Yes, I actually, this is a great question. I presented to a large group of faculty members just 3 weeks ago on this exact topic. And it's, the reality is that the auditor, the analyst, the data engineer that got us here in the ESG space is not what's going to get us there. The lines between disciplines are blurring. And so having that truly sort of interdisciplinary or multidisciplinary capability is critical to the success of an organization. Now, oftentimes that freaks people out. You begin to think, oh no, I have to go on a search for unicorns, right? And that's not the case at all. A lot of these are cross-trainable skill sets. So looking at, and as I talk to a lot of those faculty members, a lot of these universities are now in the transition, at a transition point of taking their computer science degrees or taking their business and audit degrees and crosswalking them with one another, bringing in hard science, physical science capabilities and skills. So an auditor that comes in with some GIS skills, a computer scientist that has a baseline understanding of physics and physical models and atmospheric science are a tremendous upskill and a tremendous force multiplier for an organization. So everyone's different. I would first tell a large organization to look within its own walls. You probably have more skills sitting there than you realize that you do. We certainly have been able to gather quite a deep bench of skill sets and capabilities within our organization without going and looking outside. Identify those gaps then after you've built a foundation with your internal capabilities. Identify those gaps and go out, and you don't necessarily need to hire them. There are plenty of consultants, there are plenty of universities to work with, and so we've had great success using all of these methods in terms of filling the gaps. But I do think that over the next 3, 4, 5 years, the graduates coming out of school are going to be far better versed and far more capable to wear many hats in the organization than what we've traditionally seen.
And I think the good news, if you want to think about it like that, is that nobody today, I don't think there is a person alive who's actually an expert on how to solve the problem. If there was, we would have solved it. So everybody's learning. And so to Steve's point, I think that gives an opportunity for a lot of people to learn. Myself, a long time ago, not that long ago, I used to say that my experience with climate was I experienced climate. And it's taken a while to sort of come up to speed. And I think, to Steve's point, it is so interdisciplinary that your teams, as you put them together, it's really important to get teams to work together and to cross-pollinate knowledge. As I've talked about, the different kinds of knowledge are not as a clear-cut and as specific to the job that they need to be doing. So from a team standpoint, it's really important to create a very collaborative environment. So we talked a lot about the fact that in this space, there are a lot of unknowns, and we pointed to all the unknowns that we could point to. And of course, as one of our famous folks said 15 years ago, perhaps, there are many unknown unknowns. It's one of the immortal quotes. And so in ESG, there are many of these as well. And we've thrown out a few here just to illustrate the point. And of course, the takeaway is these unknown unknowns lead to other challenges along the same vein that we discussed earlier and lead to the same conclusions in terms of people and what people must do as well. To give some examples, metrics around ESG. Today, the metrics are, I would say, fairly early stage. Steve earlier threw out an alphabet soup of various organizations that are coming around with ESG-related metrics. We can expect that to grow. We can expect that to morph and change before it settles down over some long period of time. Some of those metrics are somewhat counterintuitive. For example, certain metrics actually talk about, not when you look at the metrics, it looks like perhaps describes how green, if you like, a company is, but they may actually describe what greening might do to the company, quite the opposite of what you would expect from just being socially responsible, if you like. So the understanding how those metrics evolve, what those specifically are, they become really important, and they have all the downstream effects that we all know from reporting and so forth. The other aspect that I would point out is when we look at sources of data, and we talked about how many sources there are, how distributed those sources are, but increasingly the capturing of information is becoming better and better. To give you an example, a greenhouse gas is, at the end of the day, something that's invisible. And it could actually be coming from anywhere. It could be coming from somewhere in this room, for example, because it's not something that poisons us as such. And so if you think about a factory or a pipeline that is transporting natural gas, it actually could be leaking methane, and you wouldn't actually see it. So increasingly, as opposed to making estimates, people are thinking about how we can put IoT devices on these systems, and they again start sending data, which then go through the same pipeline. People are thinking about how to use satellite imagery to capture where the footprints are, and then drive from that estimates of various things, certainly greenhouse gases, but also satellite imagery of how forests are growing or reducing, and so on and so forth. And all of those can add more types of data to the picture, which means that the data sets, you should expect them to grow in both number and complexity, as opposed to reduce. And it's hard to predict where all that will come from. Steve mentioned Scope 3, and it's worth spending a couple of minutes on Scope 3 and the challenge. Scope 3 is actually a catch-all bucket for everything that you can't measure easily. So if I have a fire burning in my factory somewhere, that's Scope 1. If I have electricity that's coming from a power plant that burns coal, that's Scope 2. Those are easy to compute. And Scope 3 is, it's everything else, right? So it's very hard to compute because essentially your Scope 3 is someone else's Scope 1 and Scope 2. And what that means is you got to really go up the supply chain. So if I have a battery manufacturer, they've got to go back to the company that's actually building the battery, and these people might be selling it. And then they have to go, the company that's building the battery has to go back to the mining company that's mining the cobalt and the lithium, and so on and so forth. And so it goes ad nauseum. So you have essentially a chain of custody of greenhouse gas, if you like. And of course, that leads us to thinking immediately about blockchain and things like that. Again, the techniques here are very early stage. So whether these will actually work or not is an open question. But if they do work, they might simplify the problem of reporting against greenhouse gases very significantly. If they don't, of course, we have the same mess that we have today. And that's another area to think about where things could be very volatile. And the last example I want to give is around regulations. We talked about the fact that there are lots of regulations, but in this space, the regulations are exceedingly complicated because they are not only dealing, there's not even an agreement in many ways of how severely the problem should be tackled and how to tackle the problem, which means you actually have regulations that are not necessarily consistent in many jurisdictions, and the speed with which those regulations are implemented are very much subject to the political vagaries, as I'm sure everybody has been reading about in the papers more recently. So again, how fast these things will get implemented, how strongly, how will companies and organizations be dealt with that don't comply? Those sorts of things are, again, a huge unknown in this space.
Yeah, I think to sort of wrap things up, I always sort of double click on the satellite data piece. I am biased. I'm a geospatial scientist, worked in the space industry, worked with NASA for many years. But I think it's a fantastic example of exactly what Dilip is talking about. When I started my career 30 years ago, 25 years ago, I was lucky to get one satellite image a month with 5 bands. It was grainy, 30, 60 meter resolution. The reality is right now, I could get on the phone and task a satellite to shoot a photo of my house up to 100 different bands across the entire visible and non-visible spectrum tomorrow. There's been over 3,000 satellites launched in the last couple of years. There will be another 3,000 to 4,000 launched in the next 3 to 4 years. And they're collecting data now at 10 centimeter resolution, 25 centimeter resolution. They're collecting thermal imagery. They're collecting infrared imagery, shortwave infrared imagery, SAR, synthetic aperture radar data. We are able to look at, visualize, and sense the world now in a way that we've never been able to do before. And the byproduct of that is a ton of data to manage and a ton of resources. Now, and we don't know where that technology is going to go. I have ideas, I have hopes and wants, and some hunches about where it's going to go. But that's part of this unknown. But I think what is known, though, and from my perspective, is that in 25 years of working on the science side of this and attempting to understand how and why things are changing, I've never been more optimistic about change happening. It wasn't going to happen with science on its own. It happens at the nexus of business, science, and regulation. And that's where we're sitting right now with ESG. And so I absolutely encourage all of you, again, want to reiterate, get your seat at the table as a data officer, as a data practitioner, data manager. Get your seat at that table. Understand the resources within your organization and start helping out with that ESG journey.
So, Stephen, there's a question come in that, again, I think that Deloitte would be very well positioned to answer. It says, how do you see the competitiveness between organizations that are implementing ESG programs versus ones that are not?
Well, that's a question that could be answered in many ways. I do think that the public has spoken, and I do think based on stakeholder and investor messaging to many organizations that there is a desire, right, to have a better understanding of what's happening, what's going into the products that they're purchasing, what is the provenance and the life cycle of those products. So I do think it's fair to say that those that have a healthy and robust ESG program that are disclosing and choosing to disclose a wide breadth of data and information about their organization are potentially put themselves in a more competitive place.
I would echo that very much, and at this point I don't think it is a theory. I think it is practice. For example, if you look at the funding of projects of different kinds, green projects of different kinds, and we can get into details, but green projects have funding rates that are several percent, I'm talking 10, 15, 20%, not basis points, but actually this is massively different than projects that are brown projects, as it were. So very, very significant as an example. There are many examples that you can look at of companies now getting sued for what's called greenwashing, where because a lot of investors are asking for green investments of different kinds, and so the problem of putting out numbers that are not appropriate, that are not exactly accurate, actually leads to financial loss, and that financial loss, of course, translates to things like lawsuits. So absolutely, this is not theory anymore. I do believe that this is going to be only get worse. We are certainly beginning to see product companies, doing anything from groceries to packaged goods and so forth, beginning to think about how their products would be competitively differentiated, very similar to what you might see calorific values today in food. What is the greenhouse gas that is involved in something that you buy in the supermarket? And so people are beginning to think about how those might be competitive. So this is certainly a topic of the day, and it's something that I think a lot of people are increasingly aware of.
And just one last question, Kamina. I know we're coming up to the time here, but a recommendation from you guys on how you develop a global approach to ESG.
I think there are probably a few aspects to this which we have alluded to earlier, but let me see if I can sum this up. I think first, from an organizational standpoint, just like anything else, there has to be a will that comes from the leadership of the organization. For all the reasons that I just spoke about a moment ago, those are beginning to happen. Once that is in place, a couple of things from a more data perhaps and a technical perspective, it's critical to have a multidisciplinary approach to addressing this problem. As we have illustrated, I think, ad nauseum today, this is not a problem with one skill set. It's a problem that involves multiple skill sets that needs to be in place to deal with. So that is a second piece. Certainly, we wouldn't think that it would make sense to have a huge organization set up to do this for two reasons. One, you start a huge organization, it needs to start doing something, and it's a challenge to think about what that might be. But more importantly, this problem is a problem of transforming each organization from a high carbon economy to a low carbon economy, which means inclusion of all of those various parts of an organization into the transformation process, which means this is really changing the DNA of an organization. And so starting with a core team that does that is able to work with various leadership teams within the organization is critical. As Steve has mentioned a couple of times, fighting for, arguing for, explaining the reason for the seat at the table is critical because the problem is so complicated.
And I think I would add that you're not operating blind in this journey. There's these guidelines, these frameworks that I mentioned at the onset of the presentation, the TCFDs, GRIs, the GHG protocols. All of these have been designed largely with a global lens and a global viewpoint. Sure, there are going to be geographic specific regulations, and we already see that in disclosure requirements in Europe versus what's proposed in the US. That said, all of those frameworks offer a level of guidance to you as an organization to get stood up to operate, and they all boil up in one way or another to basically establishing your governance up front, just as Dilip said. And it has to be driven from top down. You have to have buy-in. Setting up one large centralized organization, perhaps that's what works for your organization. We tend to see that there are many pieces and parts and owners and stakeholders across the organization. So getting buy-in and representatives from all those is maybe our preferred sort of method for pulling together the right data, the right stakeholders. And then after you establish your governance process, it's risk and then impact. Right? So at the end of the day, it's as simple as those three things. But I would encourage you to go out and leverage those frameworks and that guidance that's out there. Align yourself with one of those frameworks and begin implementing those first steps.
Excellent. Good point. That was all the questions that came in.
I think we are right on the dot, but thank you for all the questions, and we think this is an exciting area, and I would like to end on a hopeful note that I personally believe that data and technology has a lot to do with solving the problem. And I feel fortunate that I can be in a space where I can do the kinds of things I love, which is data technology, and still pretend to be saving the planet, hopefully saving the planet. So thank you.
Hopefully saving the planet.
Thanks to everybody online.
Thank you very much indeed.